In the early 19th century, John Dalton, an English teacher and chemist, resurrected the ancient atomic idea and gave it experimental proof. In 1808, he proposed his atomic theory, built on four revolutionary postulates. 1. All matter is composed of tiny, indivisible atoms. 2. All atoms of the same element are identical in mass and properties, but different from those of other elements. 3. Atoms combine in simple, whole number ratios to form compounds. 4. In chemical reactions, atoms are neither created nor destroyed, only rearranged. Dalton didn't just speculate, he measured, observed, and built his theory upon evidence. But how did he know atoms combined in simple ratios? The answer lies in a series of fundamental chemical laws discovered just before his time. Before Dalton, the French chemist Antoine Lavoisier had made a groundbreaking discovery: matter cannot be created or destroyed. In every chemical reaction, the total mass of what you start with equals the total mass of what you end with. Mass is neither created nor destroyed in a chemical reaction. For example, when sodium reacts with chlorine to form table salt, the combined mass of both elements is exactly equal to the mass of the salt produced. This meant that atoms were not disappearing, only rearranging, a cornerstone of Dalton's later work. But that was just the beginning. Soon after, Joseph Proust noticed something astonishing. No matter where a compound came from, it always contained the same elements in the same fixed proportions by mass. A compound always has the same ratio by mass of its constituent elements. Water, for example, always breaks down into 8 parts oxygen and 1 part hydrogen by mass. Ammonia always contains nitrogen and hydrogen in a 4.7:1 ratio. These consistent numbers could only mean one thing: matter is made up of atoms combining in specific fixed ratios. But Dalton saw something even deeper. Dalton realized that when two elements form more than one compound, the ratios of their masses follow simple whole numbers. Take carbon and oxygen. They form carbon monoxide, CO, and carbon dioxide, CO2. In carbon monoxide, 1 gram of carbon combines with 1.33 grams of oxygen. In carbon dioxide, that same carbon combines with 2.67 grams of oxygen. The ratio between them, 2:1, revealed that carbon dioxide has twice as many oxygen atoms per carbon atom as carbon monoxide. These simple whole number ratios could only happen if matter was built from discrete, countable particles, atoms. We've learned that elements can combine in fixed or multiple ratios by mass, giving rise to two important laws: the law of definite proportions and the law of multiple proportions.